Hello students, today we will discuss the very important aspect of the biochemistry and which is used for the separating of most of the chemical substances, that is chromatography. So the chromatography, it's also called as the technique of separation, and in literally if you can see from the Greek, the chroma means color and graphian means to write. So color writing, the term is given by the Russian scientist and he is a botanist called as Svet. He first separated the colored pigments which is present on the leaves by pouring the leaf extract onto a column which consists of calcium carbonate, sucrose and as well as the alumina. And he got different bands and he characterized later as the chlorophyll A, chlorophyll B, xanthophyll and the carotenoids. And there are different terms in chromatography. We can discuss. The first one is an analyte. The analyte means the substances which we are going to separate, that what we are calling it as an analyte. And the two major important phases in chromatography techniques are the mobile phase and as well as the stationary phase. The mobile phase is the moving phase in certain directions, and it may be a liquid or a gas. And the stationary phase is a fixed phase, and it is also maybe a liquid and also can be a solid. And now what is chromatography then? So in definition I can say the chromatography is a technique of separation of components of a mixture to analyze, to identify, to purify the components or a compounds. And there are major two types of chromatography. One is for the preparative purposes and another one is for the analytical purposes. The preparative chromatography means just to separate the components in the chromatography technique, and the analytical means after it is helpful for the identification of the chromatography and identification of the compounds. And this chromatography technique is nowadays, it is useful technique in the separation and as well as to purification in the industry, and especially for the separation of the proteins and separation of the enzymes, which is of clinical significance. And also there are two Nobel is given for this chromatography techniques for the efficient separation of the chemical compounds. And now we will discuss what is the principle of this chromatography technique. And I have told you there are two phases, that is called as the mobile phase and as well as the stationary phase. And the separation, these mobile phase and the stationary phase are the two immiscible phases. And the compounds is separating based on the affinity or the attraction towards the mobile phase and the stationary phase. And this distribution, we are calling it as distribution coefficient or the partition coefficient. So when you add the solute to the chromatography system, the molecules will separate in the mobile phase and as well as the stationary phase. And if the solvent system is a polar solvent, if you used, and polar solvent, for example water, and if I want to separate the polar compound, then the polar compounds likes the polar solvent, so the attraction is more. So that the principle is polar likes polar. And if I am using the solvent system as a non-polar solvent, and for example any organic solvent, for example hexane you can take, for example petroleum ether you can take, and the compound if it is non-polar, the attraction is more. But if the compound is a polar, then attraction is slow. And the distribution or the attraction to these immiscible phases, mobile phase and the stationary phase, helps in the separation, and the movement of the compound in these two phases will stop when the compound is in equilibrium between the two phases. So that is what we are calling it as the partition coefficient. Partition coefficient in formula I can say K is equal to Cs divided by Cm. So Cs means concentration is in the stationary phase and divided by Cm means concentration is in the mobile phase. So this distribution, what you are calling it as a partition coefficient. So there are different types of chromatography and we can classify on the different ways we can classify. But of which the major two types we categorized as the partition chromatography and as well as adsorption chromatography. So in the partition chromatography, the substances are separating based on the partition between the two liquid substances. And here the stationary phase is liquid and the mobile phase is also liquid or can be gas. And in the adsorption chromatography, here the stationary phase is a solid and the mobile phase can be a liquid or it can be a gas. And based on this, we can classify into a column chromatography and as well as paper chromatography and as well as thin layer chromatography and as well as the gas liquid chromatography and as well as solid gas chromatography. And of which I can say there are many different types of chromatography. Paper chromatography is an example for partition chromatography and thin layer chromatography is an example for adsorption chromatography. And now in the recent days, there are based on the efficient separation, again the HPLC, high performance liquid chromatography, and as well as HPTLC, high performance thin layer chromatography is used in the industry for the efficient separation of the biomolecules. And how we can identify the compound? And this how we can identify the compound, it is based on the resolution factor or the retardation factor. So what is this RF value or the retardation factor or the resolution factor? So RF value in formula I can say it is the ratio of solute front divided by solvent front. So what a solute front means, the distance moved by the solute in the mobile phase, and the solvent front means distance moved by the solvent in the mobile phase. So this ratio will give the RF value. This RF value is unique for each substances. So it is maybe separate for chlorophyll A, chlorophyll B and xanthophyll, and each and every amino acid also it is different. So it helps in identification of the compound. So this is the basic concept and the principle of chromatography technique. Thank you.